Bright Tuty. Every student matters.
Now for the final property of metals and non-metals. For the metals is the reaction of metals with non-metals. So although we will be discussing this in quite a lot of depth in periodic classification of elements, I'll give you a brief idea of what is the difference between metals and non-metals. So metals are essentially electropositive in nature and non-metals are negative in nature. By electropositive I mean that they have extra electrons in their outermost shell which they want to give away to form a compound. Whereas by electronegative I mean that they have a tendency to get electrons. So here there are two spaces. So any atom, first of all, you know that any atom needs to have 8 electrons in its outermost shell to achieve a stable octet, then only will it be stable. So to achieve 8, anything which has a tendency to lose electrons to get 8 in the outermost shell will be a metal. Anything which has a tendency to gain electrons from another substance to get a stable octet will be a non-metal. So let's take some examples. Sodium is an example of metal because its atomic number is 11, which means it has 2, 8, 1 electronic configuration in KLM. So it has one extra electron which it wants to lose to form a new compound, and that is why it is electropositive in nature, whereas chlorine is a non-metal. Why? Because its electronic number is 17, which means its division would be 2, 8, 7. So it wants to gain one electron to make it a stable octet. So another example of this could be magnesium, potassium, calcium. All these are metals because they want to lose 1 or 2 electrons, or even 3 for the case of aluminium, and they want to become stable by forming an octet in their outermost shell. Whereas elements which want to gain this extra electron are called as electronegative elements or non-metals because they want to gain extra electrons from outside to become stable. Okay, so now that we have understood that someone is willing to, some element wants to give away electrons, others want to take it, it is obvious that they will react with one another also to form this kind of reaction. So one example, to understand this you also need to know what is an electron dot structure. So electron dot structure is essentially when you put an element and you label the number of electrons in the outermost shell using dots or crosses. This is not the configuration for sodium. I am just explaining you for an example that we use all 4 sides. So for example, this element is just take an element X. So we use all 4 sides and put 2 on each because we have 8 vacancies. So we use this kind of configuration, this kind of structure to show how many electrons are there in the outermost shell, because the inner shells don't really participate in the reaction, so they are not that important. And we show by this, if there are only 2 electrons, so then we will be having a situation say like this. If there are 7 electrons, like in case of chlorine, then we will be having 7 electrons in the outermost shell. We will be drawing 2 on each of the 4 sides to have this look clear and not that dingy that we are drawing 3 on one side. So it's always better to draw 2 on each side, and that is how you draw electron dot structure for different elements. I can give you one more example here. So let's take the example of calcium. Calcium actually is beyond your reactivity series. So let's take the example of aluminium. Aluminium has 3 outermost. So aluminium's atomic number is 13, which means it's 2, 8, 3. So if I have to draw the electronic structure, electron dot structure, I will draw 3 extra electrons in the outermost shells. I can use either dots or crosses, both work fine. We used one dot or one cross so that we can show which is coming from where. We'll do that. We'll understand this better when we do this reaction here. So this is how I would draw an electron dot structure for aluminium. Because it has 3 electrons in outermost shell, I've drawn 3 dots. Okay. So now let's understand how NaCl is formed. The reaction is Na plus Cl. So we have sodium and we have chloride, and they are resulting in formation of NaCl, which is sodium chloride. Now what is happening to the metal here is it has one extra electron, so it wants to give away this extra electron to become stable. Chlorine needs one extra electron, so it takes this electron from sodium to become stable. Now this is the chemical equation using electron dot structure, that this extra electron is given to sodium and now to chloride by sodium, and now because of this they are bonded in this ionic bond. So this bond is called as ionic bond. When one element loses electron, another element gains electrons, then it is called as an ionic bond. So by this ionic bond they are held together by giving away of their electrons. So that is how metals and non-metals react. Metals give away their electrons, non-metals receive the electrons, and they form this ionic bond by this process. Let's now do one more example from the scratch. So we have magnesium and we have chloride. First we will write both the elements. Magnesium, so we know that magnesium's atomic number is 12, which means 282. So magnesium will have Mg plus 2 electrons that it wants to lose. Then we will have chlorine, which is 287. We will have a chlorine, and it wants to gain 2 electrons. So it gains 1 electron and forms a stable chlorine, right? So this chlorine gains 1 electron to form a stable chlorine atom. Yeah. So now we know that here 2 electrons are being released, but here this only needs 1. So how does this function is that what happens is 1 magnesium combines with 2 chlorine atoms. So here there is one valency and here there is one extra space. This goes here and this goes here, which results in formation of 1 Mg which has lost its electron, combining with 2 Cl atoms. So 1 magnesium combines with 2 chlorine atoms because it has 2 extra electrons to give away, and MgCl2 is formed in this process. So that is the formation of salts or compounds of metals and non-metals. Now for the last topic for this half of the lecture is properties of ionic compounds. Now ionic compounds are these compounds which are formed by by giving away of electrons. So first is their physical nature, that they are solid and hard. That is because they have strong interionic bond holes. They have high melting point and high boiling point, again for the same reason, that different molecules here are held together by strong force. Then there is solubility, so they are soluble in electrovalent compounds like water, but they are insoluble in kerosene or petrol because they do not have polarity. Conduction of electricity, that they conduct electricity in solution form and in molten form. So in solution form they can break and form ions of Na plus, Cl minus, etc., and conduct electricity. But in solid form they do not have free flowing electrons to conduct electricity because their structure is so hard. Because of that, but if we melt the structure and make it molten, that is liquid, then they will be able to conduct electricity. So ionic compounds do conduct electricity, but only in form of solution and in molten forms. Now for the next half of this chapter, we will be taking in a separate portion where we will be discussing the extraction processes and the corrosion.